Okay, let's begin our next lesson here. And there's some challenging questions, and we're going to progress from less challenging to more challenging as we go here. All right, so let's start with this first question, a to the negative 1, b squared, all to the power of negative 2. I love this question because it really tests our knowledge of negative exponents, but also one of our power laws, which is power to power. All right, so we do have a power to power situation, okay, because there is a power outside of the brackets with powers inside the brackets. So we know that we multiply our exponents when we have a power to power. So let's do that. And I'll write out all the steps in this question, but I'll start to go a little bit faster as we go. So first, I'm going to write out my a. So I want to distribute this negative 2 exponent into the bracket so I can drop the brackets and simplify. So multiply negative 1 times negative 2 to apply that negative 2 exponent to the a. Then write out your b. So it's really just times b, and then it's 2 times negative 2. All right, and I should probably use brackets around these when I have negative values. Okay, and so what you're left with is negative 1 times negative 2. So write out your a is positive 2, right? A negative times a negative becomes positive. Write out your b, and you have 2 times negative 2, which is negative 4. So if you were to leave your answer like this, you would get almost all marks. Okay, for the last additional mark, I'm looking for you to show that negative exponent as a positive exponent. All right. So the way you do that is this negative exponent is only belonging to the 4, or sorry, to the b, right? So we're going to bring that down below in the denominator and keep the a squared where it is. Okay, the only thing we're going to be bringing down or flipping is the b, the variable b with the negative exponent. The a is happy where it is. The a has a positive exponent. It doesn't want to move. If you move it, it's going to become negative. So to finish this off, you get a squared, bring the b down with the negative 4, and it becomes a positive 4. So for the extra mark at the end, you need to make any negative exponents that you see need to be flipped and brought in the denominator in order for you to get that final extra mark there. Okay, so now this one will go a little bit faster. I won't show the multiplication like I did here. So here again, we have power to power, same type of question as the previous one. So I'm going to do negative 3 times 2. So I write my x, negative 3 times 2 is negative 6. Write down my y, and I'm going to do 3 times negative 3, which is negative 9. In this situation, again, you would be done, except we are left with negative exponents. All right? We can't do anything more to this because they're different bases. I have an x and a y. They're different bases. I can't add these exponents or anything like that. I should definitely mention that. So I'm done except for taking care of my negative exponents. And so what you do, because they're both negative, bring them both to the bottom. But then what do you put left over in the numerator? You can't just have a blank space in the numerator. What you're really leaving behind, hopefully you realize that it is a 1. All right, because remember that x to the negative 6, y to the negative 9 is really over 1. You don't show the 1, but it's there. And when you flip it, okay, the 1 stays in the numerator. Okay, next question. Just erase that there. Okay, so now again, power to power. Negative 2 times negative 2. So write down your a. Negative 2 times negative 2 is positive 4. Okay, so multiply. And don't forget to also, this -2 also applies to the b in the denominator. So multiply -2 times -3. So write down your b. -2 times -3 is +6. Is there anything more that I can do to this to simplify it? Well, ask yourself, are these the same bases, a and b? No, so I can't subtract their exponents, right? Do I have any negative exponents? No, everything's positive. So I am happy the way this is. And I forgot to put a box around that previous question. So after multiplying, even though I had negative exponents here, right? You're probably wondering, well, shouldn't you flip stuff because you have negative exponents? Wait until the end. Wait until the very end after you've simplified it as much as you can, because it may end up that the exponents may end up being positive, because here we had -2 times -2, which becomes 4, +4. So we never had to do any flipping there, because when I multiplied the exponents, they ended up being positive. All right, so wait to the very end before you do any flipping. Like, finish everything that you can finish, simplify it, and then worry about flipping things up or down. Okay, slightly more complicated. All right, so we have -6 times m cubed times n squared times -4 times m times n to the 5. So remember that this is all just one big, large multiplication. Like, if I were to write this in bad form, mind you, but if I were to rewrite this really just means -6 times m cubed times n squared times -4 times m times n to the 5. So this is bad form here, right? You want to use brackets, especially in front of the negative numbers there, the negative coefficients. But this is just one big multiplication expression. So what I'm looking to do is combining my like bases. So I have an m cubed and an m. And remember, if you just have an m, it's really m to the 1. So I'm looking to combine those. And I can reshuffle this around because it's all multiplication. Remember that you don't have to write things in a particular order in multiplication. I can shuffle all these terms around, right? Because, for example, 3 times 2 is the same as 2 times 3, right? So it doesn't matter what order you're in. It's all just multiplication. So I can combine these m's. I can also combine these n's because they're the same base. And then I have -6 and times a -4. I can actually multiply those as well. I can multiply those together because it's all just multiplication, and I can shuffle the order and multiply them together. Okay, so let's do that to start. -6 times -4 is 24. Now I have, let me write down my m. I have an m cubed times an m to the 1. Now, if I'm multiplying the same base, you add the exponents, right? So it's m to the power of 3 plus 1, right? So 3 plus 1, add the exponents because we're multiplying the same base. Then write your n. I don't have to show the multiplication symbol. Again, I'm multiplying n's together. I have n squared and n to the 5. I can add those exponents. Final step. So I've now collected everything. I've combined my m's, I've combined the n's, I've multiplied my -6 times -4. So I end up getting 24, m to the 4, n to the 7. My question to you is, can you go any further than this? Do you see any common bases? No, I see an m and an n. They're different. They represent different numbers. I can't do anything with those exponents. Do you see any negative exponents? No. So you're done. You have simplified it as much as you can simplify it. Okay? Let's get a little bit more challenging with this question. So, once again, this top here, we're going to treat exactly like the previous question. The only difference is we're now going to, at the end, worry about the denominator, but we're going to simplify the numerator first. All right, just like we did the previous question. Well, in the previous question, because it's all multiplication, I'm just going to do the 4 times 7. I can multiply those together because it's all just multiplication across the top, just like I showed you here. So 4 times 7 is 28. I have an m squared and an m cubed. So m squared times m cubed. So I'm going to write down my m, and because I'm multiplying my m's, I can add their exponents. So I can write it as a single m and then just add the exponents. Now write it as a single n, and again, add the exponents. And remember, what exponent is on this n here? It's a 1. So it's 4 plus 1. And then don't forget to write down the denominator there. Just rewrite it. Now let's clean up the numerator. So we're going to end up getting 28 m to the 5th n to the 5th over 14 m n to the 5th. Okay, so are we done? Well, do we have any common bases? Yes. We have an m to the 5 over an m, and we have an n to the 5 over another n to the 5. And we even have 28 divided by 14, which I know is 2. Okay, or 2 over 1. So reduce the fraction, you get 2 over 1. So I can do that right away. Now I can take my, so let's write down 2, and I'm going to do m. So I write out my m, but now it's 5. There's 5 m's across the numerator, and then how many m's in the denominator? 1. And if I'm dividing common bases, I subtract the exponents. So 5 minus 1, n, okay, 5 minus 5. Now, there's still this 1 in the denominator. Do I need to show that 1? Like, do I need to write that out? No. Okay, because I know that it's irrelevant. It will be the exact same answer whether I show the divided by 1 or not. So notice that I wrote them as a single m. So there was an m top and bottom, numerator and denominator. I wrote it as a single m, and then I subtracted their exponents. Okay, can you go any further now? Are there any common bases? No. Are there any negative exponents? No. So there's our final answer. So I took all of this and I was able to simplify it down to just 2m to the 4n squared. Let's do the next one. I want to remind you here that this 3 applies to every single letter and number inside the brackets. All right, so it applies to everything. So remember that the 6 really has an exponent 1, the a has an exponent 1, the 2 has an exponent 1, and then each of those has exponents of 1. All right, so we're going to distribute. We want to drop these brackets to simplify it. So we're going to distribute this 3 into all 6 of these numbers and variables. All right, so and it's power to power. So when we have a power to power, we multiply exponents. So we have a 6, and I'll show all my steps here. I'm going to do 1 times 3. Then do an a. Again, 1 times 3. And then a b. This time it's, just so you can see it clearly, it's 3 times 3. And now don't forget that this 3 also applies to everything in the denominator. So it's 2, remember there's a 1 there, 1 times 3. Another 1 there. A, 1 times 3, B, 1 times 3. Let's clean it up a little. We get 6 cubed, A cubed, B to the 9 over 2 cubed, A cubed, B to the 3. So you're probably wondering, am I finished? Well, I have numbers here that I can actually clean up and make this look a little cleaner, because I can do 6 cubed on my calculator. I can do 2 cubed on my calculator. Also, I have common bases still in my expression here. I have an a cubed top in the numerator and a cubed in the denominator. Okay, so let's go like this. Let's do 6 cubed. Keep it like this for now. Okay, and let's do a, and now let's write it as a single power. 3, subtract the exponents because we're dividing. Okay, and then b, write it as a single power, subtract the exponents. Now don't forget, there's still the 2 cubed in the denominator. We haven't done anything with that. Okay, so leave it as 2 cubed here. Okay, so everything else we move to the numerator, right? Because we wrote it as a single power. Okay, so really pay attention to this step here. The only thing left now in the denominator is 2 cubed. Everything else I brought up in the numerator because I subtracted the exponents and I wrote them as a single power. Okay, so what is 6 times 6 times 6? 6 cubed is 216. A to the power of 3 minus 3. Actually, I just realized something. This is my bad here. I realized that I made a little mistake here reading these numbers. This is 5 minus 5. 5 minus 5 is 0. Okay, so we're going to erase. This is my bad here. Sorry about that. Okay. The question is, what is any number or any letter to the power of 0? Okay, so any number to the power of 0, it actually equals 1. Okay, and I can show you why in the example that we are currently doing. So this is actually just going to actually equal 1. And I will show you. So this ends up being 2m to the 4 times 1, which is just 2m to the 4. Now you're probably wondering, how does anything to the power of 0 equal 1? And I'm going to show you right now with this example here. All right, a to the power of 3 minus 3. So if I have a cubed over a cubed, and actually let's use numbers. Let's say I had 6 cubed over 6 cubed. What would you say this equals? Well, they're the same number top and bottom, right? Numerator and denominator. This would actually just equal 1, right? 6, that's just like saying 6 divided by 6 is 1, or 10 divided by 10 is 1. 6 cubed divided by 6 cubed is also 1. But if we used our exponent laws, we would have done 6 to the power of 3 minus 3, which is 6 to the power of 0. Okay, so this is why 6 to the power of 0 equals 1. Because if we were to write it as a fraction like this, it would be pretty obvious to us that this would equal 1. Okay, so hopefully you understand that. But if not, just remember that anything to the power of 0 equals 1. And that includes a letter, right? So if you have a to the power of 0, remember that the letter a just represents a number. So it could be any number, in which case it would be 1, right? Because a just represents any number, okay? So I'm going to show it as a to the 0 in this step. In the next step, I'll clean it up. B to the 6 over 2 cubed, which is 8. So now you're asking yourself, can this be, can we go any further than this? Well, first off, does 216 over 8, let's try dividing those. And what do we get when we divide 216 divided by 8? Okay, so we get a whole number. So we can clean up 216 over 8 to be, reduce it down to 27 over 1. Okay, now do I need to show the 1 now in my next step? No. So 216 divided by 8 is just 27. So I can write out 27. A to the 0 just equals 1. So it's 27 times 1, which do I need to show the times 1? Nope. So I can just write times b to the 6. And there's nothing more I can do to this question. I don't have any negative exponents. That is it. Okay, let's erase this and let's try the final question, which is obviously going to be, let's see, a little more challenging. So let's see what this is going to end up looking like. This is about as hard of a question that I could possibly ask. I probably wouldn't even ask anything to this degree or this level of difficulty. Okay. It is a power to power question. Okay. Power to power. So remember, this -2 exponent applies to everything that you see that's within the brackets, including the 4 and the 8. Okay, and remember the 4 and the 8 have exponents of 1. So let's write this out. We have a 4, and power to power we multiply. We have 1 times -2. Then write out your x, -3 times -2. Then write out your y, and then just let me see here. Let's write out our y. 4 times -2 over 8. Remember that there's a 1 there. 1 times -2. X, 2 times -2. Y, -2 times -2. Now, I know what you're thinking, that why don't we flip things because we have negative exponents. I told you in a couple questions ago to do the flipping at the very end. All right, so because sometimes you may end up doing a multiplication and it ends up being positive. So why would you flip it and then unflip it potentially? All right, so let's see what we're left with. We got 4 to the -2. 1 times -2 is -2. X to the power of +6. See, so -3 times -2 is +6. Y to the power of -8. 4 times -2 is -8. And then 8 to the -2. 2 times -2 here is -4. Write out your y. -2 times -2 is +4. Okay, so now this looks, like I said, this is as difficult of a question as I could ask you. All right, so don't sweat it. What I suggest you do is watch my solution, watch it a few times, and then try it yourself. And then where you get stuck, you can pick up where you left off in the video and just keep trying it over and over again and get that repetition, and I promise you'll get the hang of it. All right, so I see common bases here, x's, and I see y's. I can combine those, and because they're being divided, I can subtract those. I'll leave the 4 to the -2 where it is right now because I don't want to give you too much to take in at once. Let's just worry about combining these x's. So x, 6 minus, because remember you have to subtract when you're dividing the same base, 6 minus -4. Write down your y. -8 minus +4, or just -4. Okay. And then because I brought the x and the y's in the numerator by subtracting their exponents, the only thing I'm left with in the denominator now is 8 to the -2. All right. Again, I'm going to not worry about the 4 and the 8 right now because I just want to do a little bit at once. Let's clean up my x and y. So 6 minus -4 becomes 6 plus 4, right? Do that in your calculator. A minus and a negative side by side becomes plus. So you get x to the 10. Then y, -8 minus 4. Do it in your calculator, you get -12. And of course, we're still left with the 8 to the negative 2. Okay, so now you can ask yourself, are we done? Do you see any common bases? No. Okay, do you see any negative exponents? Yes. So now all you're going to do, all right, is just whatever value or variable has a negative exponent, you're going to flip it. So here's what I mean by that. I'll leave x to the 10 the way it is because it's the only thing that has a positive exponent. I am now, because 4 to the negative 2 has a negative exponent, I'm going to bring that to the bottom so it becomes a positive exponent. My 8 to the negative 2, which was in the denominator, if I flip it up, it will become a positive 2. Okay, so look what I did there. So you can flip things. If it's in the denominator and it has a negative exponent, move it to the numerator and it will have a positive exponent. Okay, that's the trick. What about my y? My y has a negative exponent, so I want to bring that to the bottom. So it becomes just a y to the positive 12. Am I finished? Almost. I can do my 8 squared and 4 squared now, right? Because before, I have no idea what 8 to the negative 2 is. And I don't want to show my answer with a decimal. Like if I were to plug in 8 to the negative 2 on my calculator, I'd get a decimal. But by doing this flipping action, I now know what 8 squared is. It's 64. And I know what 4 squared is. It's 16. Okay. Am I done? One more step for the extra half mark is to reduce 64 over 16, because we can reduce that. 64 over 16 actually just equals 4, or it reduces to 4 over 1. So for the extra half mark, write down your answer as 4x to the 10, or 4 times x to the 10. You don't have to write that 1 now. You can just write y to the 12. And there's your final answer. Okay, so a lot of these bottom two questions were definitely a lot more challenging. What my suggestion is to you is to write these questions down on a blank piece of paper. And I mean, obviously watch my video, have your note in front of you, but try not to look at your note as much as possible. Push yourself, try not to look. Try to do the answers yourself. And as you get stuck, you can take a look at either my video or your note, and then don't stop there. Try it again. And then if you still have to look at the video or the note, then keep trying it until you can do it without looking. That's my suggestion, and that's how you kind of get good at stuff like this in math, right? These aren't problem-solving questions. This is just learning the skill set and then practicing it 10 times, 20 times. Maybe some people can do it 2 times. But the point is that eventually you can get it, all right? So just keep practicing it, and you have the benefit of having my video there so you can double check what you're doing as you go.